All right, hello. This is the video for the second part of section 3.2. And we're going to shift our focus a little bit. Before we were talking about relative minimum, relative maximum. Here we're going to talk about what's called an absolute minimum or absolute maximum. So when we have a function defined on a certain interval I, the absolute maximum is when we have a place where f of c is bigger than f of x for all x in the interval, right? So it's basically the place where we get the biggest y value, not just bigger than nearby, but biggest universally. And similarly, an absolute minimum is where we get the lowest y value. So if I have a graph like so, we'll notice local max, local max, local max, local min, local min, local min. But in terms of absolutes, this is the location of our absolute minimum. Of everything on that interval, it is the lowest point, and this is our absolute maximum. The extreme value theorem says when we have a continuous function on a closed interval, it definitely will have some absolute maximum and absolute minimum. Now, it's possible that the values we get will be repeated, right? Strictly speaking, the absolute maximum is the y value. So we might have a graph where the same y value shows up multiple times and there's like a tie, but that y value is unique. The biggest y value is unique. We just might get it more than once. So when we're dealing with a nice function, a continuous function on a closed interval, it will have a maximum, it will have a minimum. And these absolute extrema will occur either at relative extrema, which would be at critical values, or endpoints of the interval. Right? That's what we saw here. The lowest point was at a relative minimum, and the highest point was at an endpoint. Those are the only places where we'll have an absolute maximum or absolute minimum, at relative extrema, which are critical points, or at endpoints. So here's how we can find maximum minimum values. We'll compute f prime and find all the critical values. We'll make a list of all the critical values and the endpoints of the interval. And then we'll just evaluate the original function at each point on the list. We will look at all those values. Whichever one is largest gives us the absolute maximum, and whichever one is smallest gives us the absolute minimum. Let's do an example of this, and we'll do it as a word problem. So I took this out of the textbook. A fast food restaurant's profit from selling X hamburgers is given by this formula. So, there are various factors involved that obviously you're going to make more profit if you sell hamburgers, but at a certain point, maybe you're not. Maybe there's going to be a problem and it's too expensive. So we want to maximize profit. So to find an absolute, and we're doing this where X is assumed to be between 0 and 50,000. So this is our closed interval. And we have a polynomial, so it's a nice continuous function. So first, let's find our critical values. It's 2.44. And let's just notice, dividing by 20,000 really just means we're multiplying by the fraction 1 over 20,000. The derivative there is 2x. So we want to find a critical value, so we want to set this equal to 0. This means 2.44 is equal to x over 10,000, which means x is 24,400. So that's our only critical value. And our endpoints are 0 and 50,000. So we can just make a table. Here's x, here's p. The only possibility for where this maximum occurs would be at an endpoint or at a critical value. So we'll just plug these in. If I plug in 0, I get 0, 0, and minus 5,000. Right? So they're losing money. They're not even selling anything, so it makes sense that they are losing money. If I plug in the other number, and I will do this on a calculator you can't see. So we have this. I should have had this ready to go. Give me a second. I should have had this ready, but I have the answer somewhere. Okay, so if we plug that in here, we get 24,768. And if I plug in 50,000, that would be 2.44 times 50,000. I'm doing this without a calculator, which is a really dumb idea. Um, Minus 50,000 squared, which is 50,000 times 50,000 over 20,000 minus 5,000. So let's see what's going on here. I can cancel thousands. Um, and here, this would be 50,000 times 2.44. Sorry, you can just trust me when all of this is done. And then here, if I factor out a 50,000, that's actually 2.5. So we have zero point zero 0.06, negative zero point zero 0.06 times 50,000 and another. So this looks like it's coming out to negative 8,000. So what's going on here is if we make the maximum amount, which is 50,000, that's not efficient and we lose money, assuming my number there is correct. If we make the minimum amount, which is nothing, we also lose money. The maximum occurs here. Sometimes you can predict that without plugging in. We'll see more word problems later on. But when anytime you want to find an absolute maximum or absolute minimum, this method will always work. Find your critical values and just make a table. What are my endpoints? Here there are two endpoints. What are my critical values? There's just one. Evaluate, evaluate, evaluate. We're getting these three numbers as our answer. And the biggest number we see there is the maximum. So the maximum possible profit here, assuming I haven't made a silly mistake, would be $24,768. All right, that's it for this video.